Okay. Akosia. Hello.
Sir, Mr. Edia.
Deceleration is also acceleration. What is acceleration? The rate of change of what velocity with respect to time. But for acceleration, what is the nature of the change of velocity? What's the nature?
It's negative.
No, for acceleration, the change in velocity is a what? The change is a what?
The change.
Yes, in velocity is a what?
It's a positive value.
Or an increasing one.
Okay.
That's okay. Here,
Yes.
for deceleration or retardation, yes, there's a change, but this change is a decreasing velocity with time.
Yes.
Okay, so the definition serves the two purposes. Okay.
Yes, so with the acceleration is the change of increasing velocity
With
respect to time.
Okay.
And the deceleration is decreasing.
Decreasing velocity with time.
Yes, please. Thank you.
They all have the same unit, which is
meter per second square.
Meter per second square. All right. Let's move on to a new thing. Graphs of motion. Graphs of motion. We can plot, we are looking at one-dimensional motion, okay? We've discussed distance, displacement, velocity, and then acceleration. We can plot anything of these quantities mentioned with time. Time always has been an independent variable. Okay, it is up to the user to make use of the time. It is always draining. Let me use the word draining, or it is always going. It is up to you and I to make use of the time. So we describe time as an independent variable. It doesn't depend on us, but we depend on what? Time. So when it comes to graphs of motion, we are plotting the changing variables with what? Time. So what are some of the graphs we can plot in this regard? We can talk about what we call displacement slash distance dash time graph. I earlier said distance and displacement by magnitude have the same value. So when we talk about either distance, displacement or distance, we are overlooking the direction, but we are considering the magnitude. So we can have either displacement slash distance dash time graph. So either we plot a graph of the vertical axis can be displacement or distance, and then the horizontal axis is the time, the independent variable time. In physics, in your mathematics, this is your x-axis, this is your y-axis, but we have labeled the axis. The time at the horizontal, or what you will call as the x-axis, has a time, whereas the y-axis has what? Displacement or distance. Is that okay?
Yes.
So we can have a displacement time graph. Now, if you have this kind of graph, what are some of the motions, possible motions that can happen in this regard? We can have a situation where the distance covered by a body, distance covered by a body changes equally within equal time interval. Here I'll create a table. I'll create a table and put in values to help you understand. So we are using this table. This is distance, or sorry, displacement axis, whereas this is the time. We are seeing the body covering equal distances within equal time interval. So Mr. Abia covers a distance 2 meters, okay, 2 meters within each second. So at a time of 0 seconds, I haven't covered any. So the distance covered is 0. Then 1 second, 2 seconds, 3, 4, 5. I'm covering equal distances within equal time interval. So after 1 second, I've covered 2. After 2 seconds, what will be the distance covered by Mr. Adria?
4 meters.
Good.
4.
After 3 seconds. After 3 seconds,
6.
6, 8, 10.
10.
Good. So what am I doing? I'm covering equal distances within equal time interval. Okay. Now, when we plot such a graph, so this is 1, 2, 3, 4, 5. So 0 at the origin, 1, 2, 3, 4, 5. Then the displacement axis we have 2, 4, 6, 8, and 10. Let's plot such a graph. 0, 0. At a time of 1 second, the distance covered is 2. So this is it. 2 seconds goes with 4. 3 seconds, we have 6. 4 seconds, 8. 5 seconds, we have 10. Let's join the points. If you join the point, you have a straight line. You have the straight line. Can you help me calculate the slope of this graph? Can you help me calculate the slope?
Yes, please.
Okay, do so for me. So what did you get for the slope?
2.
What did you get for the slope? Yes, Stone Boy. What did you get for the slope, Stone Boy? Okay, Akosia, what did you get for? Okay,
2.
you had 2. Okay, let's see it. Let's see it. So, in determining the slope, all that you have to do is to choose any 2 points on a straight line. Find the change in the vertical, okay, divide by the change in the horizontal. So, delta, change in displacement, divided by the change in the time, gives us the slope. So, I pick any 2 points. It can be just any 2 points. It can be this and this. So, a change in S, a change in T. The maximum vertical value is 4. The minimum vertical value is 2. Divided by the change in time. Maximum 2, minimum 1. So you have 2 meters per second. Now the good thing about this, or the good news, is that no matter how you choose your 2 points, you need to have the same value as the slope. So I picked this and this. Let's pick the origin, the point at the origin, and then the point at the extreme end. So this is the triangle in question. Okay. The slope or the gradient. Okay, let me use the upper part of it. The slope or the gradient of this will be change in the vertical divided by the change in time. And what's the maximum vertical value? 10 minus the minimum value 0 divided by the maximum time value 5. Minimum time value 0. So we have 10 on 5, giving us what? Giving us
2.
2. So 2 meters per second square. All right. Now, if you have such a change, okay, such a change in displacement or distance with time, no matter how you choose the 2 points for your gradient, you have to get the same value. And so we term such motion as uniform velocity motion. What is the gradient or the slope given us? What is the slope given us here?
2.
No, but what's it? Yes, it's 2. But how do we describe this value 2? What is it?
Meter per
Come again.
acceleration.
No, look at it again. We got it's a displacement time graph, and we got what? 2 what?
Meter per second.
Go. So what do you think this value of slope represents? What does it represent?
Acceleration.
Acceleration.
What's the SI unit of acceleration?
Velocity.
This is
Velocity.
because the unit is meter per second. It's meter per second. Now, what we are learning here is that. Hello.
Did you write meter per second square or meter per second? Okay.
Yes. Okay. What we are learning from this graph is that if you plot a displacement or distance time graph, the slope would have to give you the velocity of the body. Okay. On a velocity time graph, the slope is equal to or would give you the velocity. And because the velocity is uniform, no matter any 2 point chosen, you have to get the same value. We refer to this motion as uniform velocity motion. Uniform velocity because the value of the velocity we got is uniform along the straight line. Okay, so in a uniform velocity motion, okay, a body covers equal distances in a specified direction within equal time interval. In a uniform velocity motion, a body covers equal distances within a specified direction within equal time intervals. Are we fine?
No, please.
I didn't get.
Please repeat.
Okay. In a uniform velocity motion, a body covers equal distances or equal distance within a specified direction within equal time intervals. Okay, as we have here, within equal
Please
time
come
intervals.
again.
Come again, eh? And a uniform velocity motion, a body covers equal distances within equal time intervals or within equal time interval. So the question, what is a uniform velocity motion? A uniform velocity motion is such that a body covers equal distances within equal time interval. Okay. And the other thing we've learned here is that if you plot a graph of displacement against time, the slope would give you the velocity of the moving body. So it's the slope of a displacement time graph is equal to the velocity of the body. Slope of a displacement or distance, either displacement or distance. Slope of a displacement time graph is equal to the velocity of the body. Okay. And when you have the body covering equal distances within a specified direction within equal time interval, such motion is described to be uniform velocity motion. Uniform because the value of the slope is the same along the straight line. Is that okay? We'll look at non-uniform velocity motion tomorrow and look at other graphs of motion. All right. So this is where I think I'll draw the curtains on today's meeting. Thanks for your presence. Alcosia, your hand is up.
Yes, Mr. Yeah, please. So please, is this the graph for linear motion or is displacement or time?
This is a displacement time graph. Okay, we are plotting displacement of the body against the time. So this is a displacement time graph.
Yes, please. And please, can you give me a definition for motion?
What do we say, or when do we say motion has taken place? A body is said to have moved when there is a change in what? The body's what?
Or direction.
The body's position.
Okay.
Okay. So that is when we say motion has taken place. Motion is characterized by change in position, because you can't claim to be moving when you are at the same place. Okay.
Yes, please. Thank you.
All right.
You explained the graph before.
Juviel, come again.
Explain summarize the explanation for the graph in list, please.
Okay, so if you have a displacement time graph and the body covers equal distances within equal time interval, such motion is said to be uniform velocity motion. Okay. And the uniform velocity motion, the slope has the same value along the straight line. That's why we said it's uniform. The velocity is uniform along the straight line. Now, if you have a displacement time graph, the slope of a displacement time graph would give you the velocity of the body, and this velocity is constant or uniform, hence uniform velocity motion. Are you okay?
Yes.
Please.
All right. Hey, Agosia.
Yeah.
Somebody else is coming. Her last one. Agosia, quick one. Okay, so please, if you have a question, you can send it to me on WhatsApp, okay? And I'll attend to it for you. So we'll have another wonderful session tomorrow. Okay, bye-bye to all of you.